Well, bummer. That cut me off just at the inopportune time. I was just about to get to my canceling. So this 3 and this 9, this is a product down here, remember, so canceling is possible. We have common factors. So 3 comes out of there 1 time, 3 comes out of there 3 times, and now we'll rewrite this as numerator 3 over the denominator x plus 2. And that will be our final answer. And now we've succeeded in adding 2 rational expressions that didn't have a common denominator. Granted, they're easy ones, but we have done it. Now this next one is that little trick about factoring out a negative. You see how these two denominators look almost exactly the same, but the signs of each of the terms are opposite. That's when we want to factor a negative, and we want our x to be positive, not negative, so we're going to factor a negative out of this one. So if I factor a negative out of this one, this leaves me with a positive x and a negative 2, which looks like x minus 2. And then remember, when we have a fraction with an a over a b that's negative, that is exactly the same as a negative of the a over the b. And so that's exactly what I'm going to do with it, is say, okay, that's the same as also a negative a over a negative b. And so if I had a subtraction, I would take this and I would put it out here. That's talking about it that way. But I have an addition already, so I'm going to take it and I'm going to put it up into the numerator, associate it with the numerator, so it's going to make that a negative 7. So this is going to look like 12 minus 7 all over x minus 2. And so 12 minus 7, we're going to get 5. And 5 over x minus 2. And there's not a thing more we can do with it. That'll be our final answer. All right, now moving on, we have 7 over x minus 5. And in this one, what we need to realize is this is a whole number, right? So we need to put this over x. So our least common denominator between x and 1 is simply x. So we're just building the higher term here. So we're going to write plus a minus 5, right? So we have 5 plus a minus 5, or 7 minus 5, whichever you want to do it. And then we're going to build the higher terms. And so we have our higher term here, 1 times x and x times 5. So we have there and there. And now we can add our numerators, 7 plus a negative 5, or simply 7 minus 5x. And that's all over the least common denominator. No canceling. There's no canceling in subtraction or addition. We cannot simplify that. All right, now moving on to the very last one here. Our LCD between x minus 2 and x minus 2 squared. It's the unique factor, x minus 2, to the highest exponent. And the highest exponent is a squared. So this one, x minus 2, is missing another factor of x minus 2. So we'll put the x minus 2 up here that we're going to multiply, and then this will say plus a negative there. And so I'm going to have 5x minus 10 minus 3x all over my least common denominator. I don't want to get writer's cramp, so I'm going to write that least common denominator, and then I'll simplify my numerator, 5x minus 3x, which is 2x, and then minus 10, and that's all over my least common denominator. Then I'll factor my numerator. 2 comes out of those, GCF, right? Minus 5, and then that's all over my least common denominator, and I'll put it back in this time, x minus 2, quantity squared. Nothing cancels, but it still needs to be factored. Remember, even when you can't cancel, you still have to factor. If any factoring is possible, then you have to factor, because you're not capable, or at least I'm not, and I don't figure that most people are capable. So there may be a few of you out there that would be, but where most of us are not capable of seeing a factor that's in common with a polynomial and a polynomial. So we always have to factor it. So that's my expectation. And that's why we're talking about this in our factoring chapter, because it's an application of factoring. All right, that ends our lessons